Good morning, Year 10. Happy Friday. Hopefully you like these 5 questions. They're a bit easier than they have been recently. It's Friday. I feel like we deserve a bit of a break. So these are the solutions for the 5 questions from week 3, term 3, Friday. For the graph, y equals x plus 2 all squared, identify how far and in what direction the graph has been shifted. So from last lesson, we were talking about how this number here tells us how far something shifted, and the sign tells us the direction. So the sign in this case is positive, which normally means right, but for this it means left. So for this graph, it is moved 2 units to the left. Cool, not too bad. Now for question 2, we need to use some index laws. We need to simplify a to the power of 4 times a to the power of 5. Now, the way we simplify these is the log law for multiplying when they have the same base is to add the powers. So I can rewrite this as a to the power of 4 plus 5. So those two things are together. Okay, so a to the power of 4 plus 5, that's going to be a to the power of 9. And that's it, that's simplified. That makes us happy as Larry. Now, question 3, simplify log base 2, 3 plus log base 2, 5. So bring logs back into it. Now, there's 2 ways to do this. One is faster, one's slower, but they both work. I'll show you the way I would do it first to make it a bit easier and quicker. And then I'll show you the way that it would also work, but might take a bit longer. So the first thing is to recognize they have the same base. If logs have the same base and they're being added together, we can then multiply these numbers here. Now, the reason why I'm including this after this is because it's for a very similar reason. If you want to look into it, BAP them and see what happens. So let's simplify log base 2, 3 plus log base 2, 5. It's going to be log base 2, 3 times 5. Okay, I can rewrite it like that. But we know what 3 times 5 is, so I can rewrite it as log base 2, 15. And now it says to simplify, but we actually know how to put that in the calculator, so I'm going to check what that number is. I'm going to do a change of base, log base 10, 15, over log base 10, 2. We'll see what we get. So I'm going to get log 15 on log 2 in the calculator, and it tells me it's 3.907. We'll just go to 3 decimal places. Now the other way, which in my opinion is a bit slower, and also it doesn't utilize the log laws, so you don't get the practice, but some of you may have done this, is you do change a base straight away. So I'll do log base 10, 3 over log base 10, 2 plus log base 10, 5 over log base 10, 2. And then when you put that into the calculator, you will actually get the same thing, 3.907, and that's the 3 decimal places in both cases. Now I know it looks like this one is faster, but typing into the calculator that way actually takes a lot longer, where 3 times 5, we all know that's 15, so just to type this into the calculator is only one fraction, it's a bit quicker. Next up, we've got some surds. So we need to simplify the square root of 8 plus the square root of 32. Now, we can't add them because they don't have like terms. Like if they both were the square root of 8, then we could add them together. Or they're both the square root of 32, then we could add them together. But we can actually simplify these individually, and then once we do that, we can then add them together because they'll have, hopefully, like terms. So the square root of 8, we can rewrite that as, because they can be divided by 4, we'll do the square root of 4 times the square root of 2 would be the same as root 8. And 32, now 32 can be divided by 16, and then we get 16 times the square root of 2. So rewriting that, I'm going to have square root of 4 is 2 root 2, and the square root of 16 is 4 root 2. Now we have like terms, 2 root 2 plus 4 root 2, that's just going to be 6 root 2, and we're done. So that's not too bad. But you just have to remember your perfect squares. So I'll just remind you of those. We've got 1, because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. You just keep going like that until you've got enough. Obviously, the 1 square is a bit of a waste of time, but it gets us started, and that's all that really matters with that. And yeah, you could go all day. And if you need to type those into the calculator to figure out what they are, go for your life. Now, question 5. Find the midpoint of 3, 0, and 1, 6. So this is some coordinate geometry. And the formula for the midpoint is this. x1 plus x2 all over 2. And the other one is y1 plus y2 over 2. There we go. So I'm going to label our points. This is x1, y1, x2, y2, and we'll pop them in. So the midpoint is going to be 3 plus 1 over 2 and 0 plus 6 over 2. Now, remember, we type each individual fraction into the calculator on their own. So we're going to get 3 plus 1 on 2 is 4 on 2, which is 2. And 6 on 2 is 3. So that is the midpoint of those 2 points. All right, so that's the 5 questions for today. We went over some things that really important to revise, plus something from yesterday, like our last lesson. So now go from here, we're going to look at cubics.